Welcome to our discussion on algebra and problem solving, or a fancy way of saying, let's figure out how to solve some of these word problems. Okay, the first thing to realize is that if you have A equals B, you can always substitute one in for the other. So wherever you see a B, you can make it an A, or wherever you see an A, you can make it a B. And that's very important because oftentimes we'll have a word problem that originally gets set up with multiple variables, and we want to reduce it down to just one variable, and we do that by substituting one for another based on some sort of relationship. For instance, they tell us a billiard table is 4 feet by 8 feet, and they want us to find the perimeter. We know the formula for perimeter is 2 times the length plus 2 times the width. And then we can just plug in 8 for L and 4 for W. We can do those substitutions and get rid of those variables. But if they didn't tell us it was 4 feet by 8 feet and they just told us the length was twice the width, then we could have left W as W. We could have put in a 2W for L, right, because the length equals twice the width. And then we would have got the perimeter all in terms of W. And then if they said, the perimeter equals 50 feet, what are the dimensions? Then we would be able to solve for W and then plug that back in to solve for L. Okay, so that is a property that you will use a lot. The other property that you're going to use a lot is being able to translate English into math. So you need to know when to use these symbols based on the kind of verbiage that you're going to see. So equals, obviously when it says is equal to or equals is the same as, but just the word is, was, becomes, will be, results in, those types of things all mean equal. So whenever you see that, that can translate as an equals. And then you can look the same for plus, minus, multiply, and divide. When you see those words, you know that that's how you're going to translate. All right, there are 4 basic steps for solving any kind of word problem. The first step is to understand the problem. But what that really means is you want to read the whole thing through and just get an idea for what the overall theme is. And if you can, draw a picture. So it's always a good idea to draw a picture to give yourself an idea of what's going on. Then you go back and you read it in little small pieces and you translate each of those pieces. That's where you're going to devise a plan. You're going to write down everything it tells you using these translations. Then step 3, carry out the plan, which really just means find the hidden equation. And all of that stuff that it told you, there's got to be somewhere where it relates something to something else, so you have an equation, and then it's a matter of doing some substitutions or doing some math and doing whatever you have to choose a variable, do some substitution, do some eliminations, and end up solving the equation. So step 3 is where you do the meat and potatoes of everything. And then step 4, you just look back, which basically is a fancy way of saying, check your answer, make sure it makes sense, plug it back into the original thing. Oftentimes there are certain things that you will do that will introduce a second solution that doesn't actually work with the original equation. So you get 2 solutions and one of them works and one of them doesn't, and you only figure that out by plugging them back in. Or other times you'll get 2 solutions that algebraically work, but they don't work in the context of the question. That happens a lot with things where you're dealing with area and perimeter, that kind of stuff. And you do the math and you'll get an answer of x equals 5 and negative 3. And they both work algebraically in the equation, but it makes no sense to say the length of this thing is negative 3 feet. So you throw out the negative 3 and you know 5 is the answer. So that's kind of what happens in step 4. Okay, let's look at some examples of translations. How could you translate all of these things? The sum of 7 and a number, the difference of a number subtracted from 7. Pause the video, see if you can write these down and make sure that you can get them correct. Okay, let's go through them. The sum indicates addition, so 7 plus a number. And then anytime you see a number, you can just substitute any variable in you want. Here we did S, but it could be X or A or B or whatever. Here's the next one, 7 minus D. Right, the quotient of 2 numbers just means one over another. And they said 2 numbers, so we're going to assume they're different, right? So, if we, whatever letters we choose, it's just going to be M over N, X over Y, A over B, whatever. A product of 2 consecutive numbers, this happens a lot. You have a number and then the next consecutive number, and it's a product, something times something. Well, you could use 2 different variables. You could say X times Y, But if we're two consecutive numbers, right? If x is 3, doesn't y have to be 3 plus 1 is 4? And if you start at 5, wouldn't the next one have to be 6? And if you start at 10, wouldn't the next one have to be 11? So isn't the second number always going to be the first number plus 1? Yeah, so that's what you would do. The next consecutive number is just the number you started with plus 1. So you could just say a number times a number plus 1, i.e. x times x plus 1. Okay, a difference of squares means a number squared minus a second number squared. So x squared minus 2 squared is what we call a difference of squares. Totally different than the square of a difference. That's where you take a number minus 2 and you're squaring the difference. And when you have x minus 2 squared, i.e. the square of a difference, these two things are not the same. This is going to equal x squared minus 4x plus 4. Totally different than this. So keep that in mind, please, that a difference of squares and the square of a difference are two completely different things. If they use the phrase a number more than once, they're normally describing the same number. So if they say 2 times a number plus 6, or 6 more than 2 times a number is equal to 2 times the sum of a number and 3, the a number is the same thing both times. So you just put in any variable you want. In this case, we chose n. We kind of talked about this already when we talk about a number and then the next consecutive number. We know that it's just n plus 1. If it's going to be the next consecutive odd or even, it's going to be n plus 2. Here's a basic simple example of just 10, adding 10 to twice a number. Whenever you're adding and subtracting, you got to be careful about where those things go. So if you're having difficulties, plug in a number for your variable and make sure it actually makes sense. Like I said, when we have consecutive integers, we're just going to add 1. Then the next one's going to be add 2. If we're consecutive even or odds, right? If you went from 3 to 5 to 7 to 9, those are consecutive odds. From 3 to 5 is plus 2. From 5 to 7 is another plus 2. From 3 to 5 is plus 2. From 3 to 7 is plus 4. So you can see it would be n plus 2, n plus 4. And the same thing goes for evens. If you go from 2 to 4 to 6, 2 to 4 you add 2. And then up to 6, you've added another 2, so it's n plus 2, n plus 6. If you need to find 3 consecutive integers, not even or odd, just 3 consecutive integers whose sum is 41, you know that the first integer is x, the next one is just x plus 1, the third one is just x plus 2. You add those 3 together and set equal to 42. Do the math. Very simply, you get that x equals 13, and then you add 1 and add 1 again, you get 13, 14, 15. Okay, how about distance relationships? Well, anytime you have a question that involves distance, something like this, a lot of information, you got total distances between two things, and you got a bunch of cities en route, and they tell you there's some relationships between some of them, and then how far is it from Rochester to Syracuse? Well, draw a picture. And by a picture, just draw a line and label your cities in order. You don't have to worry about, oh, this distance is the same as this distance, but they're not the same distance apart. Who cares? It's just a matter of which city came first, then which, and then where did you end up, right? So, what's their ordering? And then the question is, what's the distance from blank to blank? In this case, what's the distance from Rochester to Syracuse? You try to find this distance right here. Now, you could start labeling these distances as, A, B, and C, and we're looking for B. Or you can kind of leave them kind of written in words. The distance from B to R plus the distance from R to S, distance from S to T, has to equal the distance from B to A. Because if you look at the question, B to A is the same thing as these three pieces put together. Well, then you can start doing some substitutions. You know the distance B to A is 293 because they told you that, the distance from Buffalo to Albany. And now we've gotten rid of one of our variables, right? These are basically 4 variables. They're 4 unknowns. We don't know this distance, this one, or this one. We substitute here, we have one less. But they also gave us some other information. They told us that the distance from S to A was 57 more than the distance from this. So if you add 57 to it, they're equal, and now we can make a substitution. Same thing here, they gave us a relationship between these two, and by substituting both of them in, we can turn them into just another version of the distance from B to R. So now everything's going to be in terms of Buffalo to Rochester. And once you have that, instead of calling it Buffalo to Rochester, you can just call it D for distance. Plug those all in, right? D plus 14 plus D plus 57 it gives you 3D plus 71. You move the 71 over, you divide by 3, and now you know it's 74 miles from Buffalo to Rochester. Are you done? No, because that's not what they asked. They asked for Rochester to Syracuse. So you got to go back and go, oh, that's right. They told me Rochester to Syracuse was 14 more than Buffalo to Rochester. So you just add 14 to it, and you get the answer of 88. The look back step is just to plug everything in and make sure that it all adds up to what it's supposed to add to. So if you use all the relationships, you get 74 here, 88 here. You know this one was 57 more, so that's 74 plus 57. And if you add all those together, it should equal 293, and they do. So check. We didn't make any mistakes, and we know that that's our answer. Okay, another group of questions that comes up a lot are Pythagorean relationships, i.e. things that deal with right triangles, right? And good old Pythagorean theorem, a squared plus b squared equals c squared, very popular. You guys, I'm sure, all know it. You've done it so much, it's ingrained in your psyche. You'll never forget it. So it's a good one to use because we all know it. Now here's something that doesn't use it. This just uses a right triangle and the idea that if we're trying to find area, we know it's 1/2 base times height. And it says if the area of a right triangle is 1 square unit and the height is 2 units longer than the base, can we find everything? Well, all we have to do is take all that information and plug it in. They told us the area was 1, so there's my 1 here, and it's still 1/2 base times height. The next thing they told us is what the height was 2 units bigger than the base, so base plus 2 equals the height. Plug this in for height, and now we get everything in terms of bases, right? So we get 1/2 base times base plus 2. So instead of base, we're just going to use a little b. 1/2 b times b plus 2. We want to get rid of the fractions, so multiply both sides by 2. Then we want to get rid of the grouping objects, so we actually distribute the b through. And now we notice we have a b squared, a b, and a constant, so that's a quadratic. We're going to bring the 2 over here because the only way to solve a quadratic is to set it equal to 0. Now we have this. We can try factoring it. We know it would be a b, and then a 2 and a 1, but that doesn't work for the middle term. So the only thing that's going to work for us is our friend, the quadratic formula. Again, another one of those formulas that you probably know. And as I've said in other videos, you want to actually tell yourself what is A, what is B, what is C. So write down A equals blank, B equals blank, C equals blank. In the case of this one, you would say A equals 1, B equals 2, C equals -2. And then you plug it all to the formula. You don't make any mistakes. Like you don't forget that this negative is here, which makes this a positive. So now you've got 8 plus 4, which is 12. 12 isn't a perfect square, but you reduce it as much as you can. You take out the 4, which becomes a 2, right? And then now everything's reducible by 2. So you just get -1 plus and minus √3. Okay, but remember, these are supposed to represent the lengths of things, right? The length of the base. Is it possible to have a negative length? No, it's not. So -1 minus √3 doesn't work, but -1 plus √3 is a positive number. So that has to be the base. And then the height has to be that number plus 2. Then we can get the hypotenuse using the Pythagorean theorem. But if you're going to do that, do not use the rounded numbers. Don't take this and square it, take this and square it and add them together and then take the square root, because both of those numbers are approximations. You've rounded. And when you round and then round again, you compound those errors and you're going to get an answer that's wrong. It's much better if you can go back to the original and kind of leave them in terms of, well, the answer was -1 plus √3 and 1 plus √3, right? Those were our answer before we made it a decimal was just -1 plus √3. And then when we added 2 to it, it ended up becoming 1 plus √3. So those are our two lengths. As let's say, accurate numbers because they have radicals instead of decimal approximations. Now, if we square each one of those, takes a little foiling, but it's not too difficult, and the middle pieces cancel out, and you just get 8. Then you take the square root of 8, which gives you this. Now you take all of those answers that you computed and you round them to the appropriate. Now, if you're going to have trouble doing this and you really just need to use the decimals from the previous example, my suggestion to you is every time you have to round, you have to add 2 more decimal places. So because your final solution needs to be 3 decimal places, if you're going to use these 2 numbers, take them out to 5 decimals, right? 3 plus 2, 3 plus 2. Then square those numbers, add those together, take the square root. And you should, when you round back down to 3, even though you now have compounded your errors, you took the decimal out far enough that those errors aren't going to creep back in, and it's still going to be accurate to 3 decimals. So the rule of thumb is always give yourself at least 2 more decimals. If you can do more, right? Depending on how much memory your calculator has, leave it all the way out to there for both of them, and then square those and square root them. Okay? That's it for this video.